The triangle inequality theorem says the sum of the lengths of any two sides must be greater than the length of the third side. So here if we have sides A, B, and C, A plus B has to be greater than C, B plus C has to be greater than A, and A plus C has to be greater than B. Okay, so example 1. The measures of two sides of a triangle are 5 and 8. Find a range for the length of the third side, x. So we have three sides, 5, 8, and x. Okay, so then we're going to take a combination of them. So I always start with the numbers that are given. 5 plus 8, 5 plus 8 are greater than x. 5 plus 8 is 13, so 13 is greater than x. Okay, then I have to do 5 plus x has to be greater than 8. Well, simplifying that, subtract 5 from both sides. 8 minus 5, x is greater than 8 minus 5 is 3. And then what about if we do 8 plus x has to be greater than 5? Well, x is greater than 5 minus 8 is negative 3. Can't have a negative number here for a side of a triangle, so that does not work. So we have 13 and 3. Let's put it into an inequality. 3 comes first, then 13, x in the middle. If you look here, x, or your sign, is opening up towards 13, and on your next one, your sign's opening up towards x, so it has to open up towards x. Okay, so the side lengths for my third side of this triangle could be between 3, so it has to be greater than 3, but less than 13. Example 2, is it possible to form a triangle with the given side lengths? If not, explain why not. So make sure when you're adding these together, it's greater than the third side. So 3 plus 4, is that greater than 6? 3 plus 4 is 7. 7 is greater than 6, so that's good. 4 plus 6, is that greater than 3? Yep. And then I always move to the outside. 3 plus 6, is that greater than 4? Yes, so yes, these side lengths will form a triangle. What about our next one? 6 plus 9 is greater than 15. 6 plus 9 is 15. So no, because 6 plus 9 is equal to 15. That number has to be greater than 15. This sign right here is greater than 15, not greater than or equal to 15. So since 15 is equal to 15, those three side lengths would not form a triangle. And then our next one, start with your first two numbers. So 2 plus 5 greater than 8. 2 plus 5 is 7, so no. And no. 2 plus 5 is 7. 7 is not greater than 8. The measures of two sides of a triangle are 2/3 and 5/2. So find a range for the length of the third side. So again, our third side, x. So 2/3 plus x has to be greater than 5/2. That would be if I subtract 2/3 from both sides, so I'm subtracting 2/3, x is greater than 11/6. Then do it again. So 5 plus x is greater than 5 halves plus x has to be greater than 2/3. So if I subtract 5 halves here, subtract 5 halves, x is greater than, so 2/3 minus 5 divided by 2, negative 11/6. Again, you cannot have a negative side length, so that doesn't work. And then we have 2/3 plus 5 halves is greater than x. So 2/3 plus 5 halves is x, or it's greater than 19/6 is greater than x. Okay, so those are the two that would work. 11/6 and 19/6. So let's put this into our inequality. X is in the middle. 11/6 is our smaller amount, and then 19/6 is greater. Then look at your sign. So here, our inequality sign is opening up towards 19/6. And over here, our inequality sign is opening up towards x. So that is going to be our final answer. Okay. Then the sides of the triangle are x plus 3, x plus 7, and 3x plus 1. Determine the possible values of x. All right, so I'm going to split this up, and to kind of help us a little bit, I'm going to label this. So this is side A, side B, and side C. So my first inequality, I'm going to take A plus B, and that has to be greater than C. So A is x plus 3 plus b, so x plus 7, has to be greater than 3x plus 1. So solving this, I get 2x plus 10 is greater than 3x plus 1, minus 2x, 10 is greater than x plus 1. Then I get 9 is greater than x. And then for my next one, if I did a plus b, let's do a plus c is greater than b. So x plus 3 plus 3x plus 1 has to be greater than x plus 7. So 4x plus 4 is greater than x plus 7. So I end up getting 3x, and then if I move the 4 over here, is greater than 3. So x is greater than 1. And then our last one that we haven't done, we've done the two outside. Let's do b plus c. So b plus c has to be greater than a. b is x plus 7. We're adding it to c of 3x plus 1. And that has to be greater than a, which is x plus 3. So 4x plus 8 is greater than x plus 3. And then again, solving this, 3x plus 8 is greater than 3. 3 x is greater than negative 5. X is greater than negative 5/3. Can't have a negative number, so that's not going to work. So to write our inequality, we have for our final answer 9 and 1. So 1, then x, than 9. Then to write our signs, we look here. With the 9 and the x, our sign is opening up towards 9. Here, our sign is opening up towards x. So our value of x needs to be between 1 and 9. All right, angle restrictions. So in a triangle, AB is less than AC. Find the upper and lower restrictions on the value of x. So AB is less than, so AB is less than AC. That means AC is greater. So 3x minus 5 is the greater angle. So I'm going to say that AB goes with x plus 1. So x plus 1 is less than 3x minus 5. And I got that just from this statement right here. AB is less than AC. Side AB corresponds with this angle right here. And side AC corresponds with 3x minus 5. Then if we solve, subtract x, 1 is less than 2x minus 5. Once we're there, that's only one restriction though. The other restriction is the fact that we're dealing with a triangle. We know through the triangle sum theorem that all of the angles in the triangle has to be equal 180. So these two angles together should be less than 180 degrees. But if I add my two angles together, so 3x minus 5 plus the x plus 1, that's only two angles. So I know those two angles added together need to be less than 180 degrees. So 4x minus 4 is less than 180. Is less than 184. And x is less than 46. So those are my two restrictions. So x has to be between 3 and 46. So that is going to be my final answer.